So A, it has no striation. That's incorrect. They both have sarcomeres. They both have striations. B is also incorrect, right? They both have sarcomeres that are parallel. It's connected, its contractions are not regulated by the troponin-tropomyosin system. Both cardiac and skeletal muscle have the troponin and tropomyosin system. Hang on here. Okay. And then D, it is extensively connected by gap junctions. And we know that cardiac muscle is extensively connected by gap junctions. Skeletal muscle, we do not see gap junctions as such, okay? And so the correct answer here was D, which many of you selected. So no gap junctions in skeletal muscle, it's definitely in cardiac muscle. Can anyone remember which type of smooth muscle has gap junctions? So we talked about two types of smooth muscle. One of them had more prevalent gap junctions, and the other had little to no gap junctions. Excellent, yeah, so single unit smooth muscle has gap junctions, and that's what allows it to act as one cohesive synchronous unit. Okay, let's look at another question here. All right, last 10 or so seconds. Okay, let's see. All right, so a lot of response for D. What is the primary purpose of the cardiovascular system? So A, to bring oxygen and nutrients to cells, that's true. B, cellular waste removal, also true. Hormone transportation, also true. And so the most appropriate answer here would have been D, all of these are equally important. All right, so these are some of the major functions of the cardiovascular system, sort of none more important than the other, all are equally important. All right, so let's head to start the cardiovascular system now. Let's kind of shift gears here. So our first objective is to have a general understanding of the components that make up the cardiovascular system. So we're going to start out by looking at some of the functional anatomy in this first packet. We'll then get into some of the electrical activity, and then later on talk about the cardiac cycle and cardiac output. So sort of how the heart is regulated. So our first objective is really to talk about the structures that make up this system and some of the functional aspect of those structures, why they're important to the function of the cardiovascular system in general. Now, before we kind of get into the components and the functions, the cardiovascular system is a really important system. It's usually correlating to overall health. So when the heart is doing well, all of the other organ systems can thrive. But when the heart and the blood vessels are not doing well, we usually see there are usually consequences that we see for many other organ systems. Usually when we see things like a kidney failure, there's usually decreased cardiac output. And so it's usually, we can trace that problem back to the cardiovascular system and the circulatory system. So really important central system to the general health and general well-being, general function of many of our other organ systems, especially the brain. So the components here are going to be the heart itself, which is really a muscular pump. We've got the blood vessels all throughout our body, different sizes, and we'll talk more about that next semester, but it's certainly a part of the cardiovascular system. And then we have the blood itself, which is also an important component, right? The blood has important clotting factors that help with, repairing injured vessels and so on and prevent bleeding. And so it's also an important component when we look at the overall cardiovascular system. Some of the purposes here of the system: to transport substances such as oxygen and nutrients to the cells, as I mentioned earlier, to many, actually all of our other body systems, including the heart muscle itself. It's also going to remove waste products from cells to liver and kidneys. Byproducts of metabolic processes are removed. Carbon dioxide is circulated to the lungs to be removed. And so waste products are also circulated in the system as well to be removed from the body. And then another really important function here is the transport of hormones. Okay, we talked a lot about the hormone axis. And so the hormones use the blood as a mechanism to travel out to their target organs. And then those tertiary hormones also use the blood to travel out to have their effects as well. We've got immune cells, so our T cells, B cells, these circulate using the blood. Our clotting factors, clotting proteins can also use the blood as means to circulate to their relevant target cells or areas of repair. So here is a schematic of the heart and really a good starting place to start looking at some of the structures that are included in the cardiovascular system. So we've got the muscular pump itself. We've got two ventricles, which are inferiorly located. We've got two arteries, which are on top of the ventricles. And so the arteries are going to be our receiving chambers, and the ventricles are going to be our pumping chambers. And so as we can appreciate here, the ventricles are going to have a much thicker muscle, especially the left ventricle. The left ventricle has to pump blood out, and it has to face the resistance that's present in all of our vasculature. And so the left ventricle usually has a slightly thicker muscle than the right ventricle, and both ventricles are thicker than the atria as well. We've also got valves present, 4 valves present, and the valves are really important to keep the blood flowing in one direction, so keep that unidirectional flow. And so we've got the aortic valve that secures the ventricle to the artery. We've got the bicuspid valve here that is between the atria and the ventricle. And then we've also got the tricuspid and pulmonic valves on the right side. And we'll talk more details about the valves, but really important to understand the valves help the blood to flow in one direction. So into the atria, from the atria down to the ventricle, from the ventricle out into another artery, and then it can keep going through the circulatory system. I also want to point out some of the major vessels here. So we've got some major vessels on the right side of the heart. We've got the inferior vena cava. This is bringing blood back, deoxygenated blood back. So it's shown here in blue to the right side of the heart. So it's going to enter the right atrium. Likewise, the superior vena cava is also draining deoxygenated blood from the head and upper limbs down into the right atrium as well. And so the right atrium is our main receiving chamber. It's bringing all of that deoxygenated blood back to the heart. It's going to go from the heart down into the right ventricle through this tricuspid valve. Once it's in the right ventricle, it's now going to get squeezed or pumped out into the pulmonary artery. And so here's the pulmonary artery. It's going to have to go past the pulmonic valves as well, or the pulmonary valves. And then from the pulmonary artery, it's going to go into the lungs. And so there's a huge misnomer with the pulmonary artery. Although we call it an artery, it's actually carrying deoxygenated blood. And usually an artery is a vessel that's carrying oxygenated blood. And this is one of the locations in the body that we see that an artery actually has deoxygenated blood. But because of its pressure, because it's leaving the heart, we still consider it an artery. And it's going to take that blood into the lungs, left and right. So the pulmonary artery is dividing into left and right branches here. It's going to give that blood to the lungs where it can be reoxygenated with fresh fresh oxygen that's coming in from the respiratory system. And then from there, that blood will leave the lungs once again. It's going to re-enter the heart via the pulmonary veins. And so here's another misnomer, right? These are veins, but because they're entering the heart, although they're carrying oxygenated blood, we still refer to them as veins. And so a vein in the truest sense is going to be a vessel that's bringing blood to the heart, whereas an artery, again, in its truest sense, is going to be a vessel that's taking blood away from the heart. And then so from the pulmonary veins, we re-enter this time the left side of the heart, so the left atria here, and then through the bicuspid valve, this valve is also called the mitral valve, down into the left ventricle, and then from the left ventricle up into the aorta again. And so I just wanted to spend a couple seconds just really explaining the circulation and how blood moves through the cardiovascular system, through the pulmonary system, and then eventually through the systemic circulation, just as a backdrop for everything we're going to talk about here on. And you can see a little GIF here that kind of shows how that flow happens. So into the left atria, down to the left ventricle, up into the aorta. This is going to go out to the pulmonary to the systemic circulation from the left side of the heart. And then the right side of the heart, we go into the right atria, down to the right ventricle, up into the pulmonary artery, and then into the lungs. Okay. All right, and so in this little drawing, I usually take this opportunity to kind of explain what I just explained. So I'm gonna do that one more time here. So we've got blood that's leaving the lungs, it's carrying fresh oxygen. It's leaving the pulmonary circulation at this point. That is the blood that's going into the lungs itself. It leaves the lungs, so this should be representing a pulmonary vein. All right. So let's go ahead and actually make that note here. So this should be all right, guys, my writing pad isn't giving trouble today, so you can probably just put this in on your own notes. So here should be a pulmonary vein going back to the left atrium. From the left atrium, we go through the bicuspid valve into the left ventricle. From the left ventricle, we go through the aortic valve into the systemic circulation. So this is where blood is moving through the aorta, through all the major arteries of the body. And then at the various capillary sites, this is where we have that capillary exchange. So oxygenated blood is diffused into those tissues. Deoxygenated blood is returned into the veins, into the venules, which become veins. And then we've got that deoxygenated blood making its way back to the right atrium. From the right atrium, it's going to go through the tricuspid valve on the right side of the heart, then into the right ventricle, then through the pulmonic valve, and then back into the pulmonary circulation again. And so as we can see, the main point of the heart is to provide the pressure that pushes this blood throughout the circulatory system, the systemic system, in order to give oxygen to tissues and to pick up waste products such as carbon dioxide. And then we've got blood moving into the pulmonary circulation at the top here. And the whole purpose of the pulmonary circulation is to reoxygenate that deoxygenated blood to get fresh oxygen diffused that's coming in through the lungs. And so we can, to keep the cycle going in order to bring oxygen to our tissues and take carbon dioxide and other waste products away.